Thank you so much. Was it okay for the most part? Yeah. One of our goals for this next topic, topic 9, is to start working on how to take a timed test. I know. My natural tendency is to want to let you use all the time because I myself am a slow test taker. I just took a test actually to add a chemistry certificate to my US teaching license. I had to go to Hong Kong and do it. I did well on it, but I worked right up to the, thanks Fanny. Thanks guys. I worked right up until the end. I used all of the available time because that's just how I process the things. I mean, I'm slower than a lot of other people. That's just how my mind works. I have to see things visually. I like to write things out. And I know you guys are like that too. However, you have a high stakes test that you're preparing for, right? And that test it's a timed test. The paper 2 test is for SL students is an hour and a quarter. And it's about twice as long as this one that you just took. Yeah, so, and it's proportionate for the HL2. So it's something we're gonna start focusing on for the remainder of the year and hopefully into next year. So we'll talk about that more later. But I just wanted to let you know that's on the horizon, developing that skill. Sorry. Are you okay? Okay. Okay, so in the remaining time though, I just wanted to introduce our next topic. We have 2 more topics, what's called redox chemistry, which is topic 9, and organic chemistry, which is topic 10. And then you guys are done with the SL portion of the course. Yay! Which, especially if you're an SL student, is going to feel very comforting when you come into the school year next year. We probably won't completely finish topic 10, and I've said that before, but we'll get started with it. So, just a quick introduction, so that when I'm going to just give you a little bit of homework for our next class, because, wait, today is Wednesday, so I'm not going to see you again until Tuesday. Okay. Yeah, so that's a long time. It's a week. So I actually will probably give you more than just a little bit of homework, just so that you can start working on the redox. It's the unfortunate thing about our AB schedule. So yes, I will do for a week. So topic 9 is called redox. You may have heard of that term before. Redox is 2 terms of chemistry, 2 words, vocabulary, combined together. Anyone know what they are? What the RED and the OX means?
Oxidation.
Oxidation, good? Reduction, yeah. So we have reduction and we have oxidation. Reduction, oxidation. And in chemistry, as you learned in acid-base chemistry and other topics, we have multiple definitions for the same idea. So there's multiple ways to define an acid and a base. There's also multiple ways to define a reduction-oxidation reaction. The way we're going to define it for this is we're going to use this term oil rig. Everybody knows what an oil rig is, right? It drills for oil out in the sea. So oxidation is loss, and reduction is gain. Loss and gain of what, you might ask? Loss and gain of electrons. So redox chemistry is focusing on the movement of electrons in a reaction. The movement of electrons in a reaction. So reduction is a gain of electrons and oxidation is a loss of electrons. And the example that I'm going to give you, typically in redox chemistry, we look at electrochemistry. That's a very common way to study the chemistry of electricity. current charge. But I'm going to start off with a different reaction to give you an example. And this is a reaction you've all seen before. This is, take 2 moles of aqueous HCl, 1 mole of magnesium, and what do you get? Turn to a partner and tell them.
MgCl plus H2.
This is an acid-base equation, right? We have an acid in the middle. So what are our products? Hydrogen gas and magnesium chloride, which is a salt, right? Hydrogen gas. Magnesium chloride. Not very sufficient. So the reason that I want to start with this equation is we can look at this in terms of redox chemistry as well. And so I'm going to break it down a little bit. And I'm going to say HCl is a strong acid, right? So in solution, what happens to it? It dissociates completely, right? It breaks apart completely. So in an aqueous solution, what I really have are 2 protons. And solid magnesium. And then I get my H2 gas. But I can look at this because this is an ionic compound, right? And it is an aqueous solution. So what happens to this? Are they stuck together, the magnesium and the chlorine? They separate, right? Because they're ionic. So when they're dissolved in a solution, in water, they're separate ions. So I could also look at this as being magnesium 2+. And in this case, my chlorine atoms, or ions, are considered spectator ions. And that's a term you guys have heard before. Some of you have asked me about it. They're already using it in the book. But chlorine, or rather the chloride ion, is considered a spectator ion. What is a spectator?
Doesn't participate in the reaction.
Yeah, or just in general terms, a spectator is someone who watches. You can be a spectator at a football game, a spectator at any sort of event. You sit on the sidelines, you don't participate, you just watch, right? So we look at it this way. Have a think about this with someone near you. Do you see the movement of electrons in this reaction? You have to talk it out. Do you see electrons shifting place when we write the reaction that way?
From the magnesium to the hydrogen.
So hydrogen becomes positive to magnesium, and oxygen becomes neutrals because it lost the gain
Okay, so I heard some good ideas here. This one, magnesium, is going from solid magnesium to a 2+, yeah? So what happened to this? It lost 2 electrons, right? So magnesium lost 2 electrons. What happened to hydrogen? Hydrogen gained 2 electrons in this process. So magnesium lost 2. So magnesium oxidized, correct? Because oxidation is lost. So we would say the magnesium oxidized and the hydrogen reduced. The reason I'm starting with this example is because I think it's important to realize that we learn chemistry in discrete topics, topic 8, topic 9, topic 10, because that's how we can process all the information. That's how we can come to understand it. If we learned it all combined together, it would be way too complicated. But chemistry isn't really like that, and I think it's important that you are aware of that. So this is an acid-base equation, but it's also a redox reaction, right? It's also an I guess that would be exothermic, but if you're looking at a neutralization reaction, that would be an exothermic reaction. So all of the topics that we learn are blended together. And it's the way that we choose to look at it and the way that we choose to describe it. So in this case, whereas previously, last week, we talked about the properties of acids and metals when they combine, we're still doing that, but we're looking at it from the perspective of electron movement. And so that's the purpose of redox chemistry, is to study and analyze how the electrons, where they go in reaction, okay? So, two final new terms to add to this. They seem easy, but they can get a bit complicated, because it's easy to flip. When we talk about something that's reduced, something that is getting reduced is oxidizing something else. Does that make sense? Yeah. And so redox chemistry, this is written as one word because it always occurs in pairs or together. If something is getting reduced, it is oxidizing something else. If something is getting oxidized, it's reducing something else. Does that make sense? So we would call the species that's getting oxidized the reducing agent. So that's another way of talking about it. The reducing agent. And what would we call hydrogen? Oxidizing agent, right? Seems pretty simple. And if we think about what the word agent means, just in common everyday English, what does the word agent refer to?
Do something.
To do something, yeah. Like a secret agent spy has a job to do, and they carry it out. So does an oxidizing agent or reducing agent. That's what they do. And in the process of doing that, that species becomes the opposite. So in the process of oxidizing something else, it becomes reduced. Okay? So to get a little bit of practice with that before you leave, which you have to leave very soon, so we probably won't have time. But we have a couple minutes, so, because that clock is fast. So if you grab an old book and you turn to page 311, and if you just look at number 2, it says for each of the following redox reactions, identify the oxidizing agent and the reducing agent. So while you're here with your fellow students to get a handle on that vocabulary. So this one right here. Yeah, okay, so we have copper going from solid copper to a copper ion. So is it losing or gaining electrons?
It loses electrons.
It loses electrons, right? So if it loses electrons,
It's the reducing agent, right?
it's being oxidized, right? So it's the reducing agent.
This is the oxidizing agent.
So go through those together so that you agree on them and identify oxidizing agent and reducing agent. These are hard both.
The CH2 minus. Because it's the oxidizing agent.
Where are you?
Because in here it's CH2 minus and when it's an ion. Then it gains electrons. So it's the oxidizing agent, right? It
It's simple, but it's not because it's easy to flip around. So you need a lot of practice with it.
oxidizing agent. No, because we're only doing one of each. each. We're not doing all of the. Obviously, there's gonna be like another one. Oh, because Saki was like, why are they all oxidized agents? And I was like, oh, it's because they're only doing one of these.
What do you mean?
Oh, because we were looking at like copper and then we moved on to the next silver. So
Oh, I see. Yeah, but the iron is getting reduced, right? So that's the oxide.
For a second, I was like,
What's that? Calcium? Oh, this is trickier. Calcium. We have to think of this as solid calcium, right?
it's
So
basically
here,
petroleum oxide.
it becomes
Comes out. You know how it's impossible to get off with like water? Comes out.
So is it
I put it there, I rubbed it a bit, I took a tissue and like
it's easily
black.
So it is oxidized, and so it is the reducing agent. And the opposite is true with the
It's different. No, I have two different ones.
same thing, right? Here you have solid magnesium. Here it becomes what?
Two different ones.
Mg.
This is my hottest bomb.
Mg. Oh, but this is a salt, right? So we'll break it apart in a solution.
This is like
It's
all
an-
in one side of it.
So in order for magnesium to be a compound with oxygen,
And use it
it has to
like
be
this is like
right?
magical study.
So what charge is magnesium?
If you have cuts, you have to put it on. Because it's like petroleum.
Oh, yeah, this is the second group, right? We're 2+. So we went from magnesium solid with no charge to 2+, and it's oxidized, so it's a reducing agent. All right, I know you guys have to go. So if I could have your attention for just a second. What I want to work on over the week that I don't see you is assigning oxidation states. So I'm going to make you a short video that goes along with the book so that you have a little bit more help, and then you can work on that for homework. And then we'll just continue where we left off on Tuesday. Have a good holiday.